Hi students, and welcome to today's lesson. I'm Mrs. Baidani. Today we will explore the question, what happens to matter during heating and cooling? Are you ready? Grab your pencil and your science journal and let's get started. In our last lesson, we heated a beaker of ice cubes on a hot plate. The ice cubes melted into liquid water, and that liquid water got pretty warm. When we measured the temperature of the water after heating, the water was 35 degrees Celsius. Then, at the end of our lesson, you made a prediction about what would happen to the water when left in the room overnight. What did you predict? Here is the beaker of water that I left out overnight. Let's make some observations. What do you notice about the water in the beaker? Maybe you notice that the water looks the same as it did in our last lesson. The water is still liquid, and the water still takes the same shape of the container. What do you wonder about the water? I wonder what the temperature of the water is now. Are you ready to find out? Look! The temperature of the water is 26 degrees Celsius. What happened to the temperature of the water overnight? The temperature of the water went down or decreased, which means the water cooled down. Why do you think the temperature of the water decreased? Well, we stopped heating the water, and we put the beaker in a cool room overnight. The water got cooler because the room is cool. Cooling can decrease a material's temperature and cause other changes in the material. But wait! Why do you think the water did not turn back to solid ice cubes when it cooled? Well, the water is 26 degrees Celsius, which is also the temperature of the room. But the temperature of the ice cubes was 0 degrees Celsius. I don't think the temperature of the room is cold enough to turn the liquid water into ice. We need a lower temperature to freeze water. Remember, freezing is a change of matter from liquid to solid. Water freezes at 0 degrees Celsius. Let's add cooling to our cause and effect chart. We will write cooling in the cause column. And what is the effect of cooling? If we cool a liquid to a low enough temperature, the effect of cooling is freezing, when a liquid turns to a solid. Let's observe more changes to the water as we continue to investigate the question, what happens to matter during heating and cooling? Today we will observe the properties of this sample of water before heating, while heating, and after cooling. Let's get started. What do you notice about the properties of the water before heating? I notice that the water is clear and liquid. And do you notice that the water takes the shape of the beaker? I noticed that too. Now let's place a beaker of water on the hot plate and set the temperature of the hot plate to high. What do you think will happen to the water in the beaker while the water is heating? I think the water will get hotter, don't you? Maybe the water will start to bubble. Wow, what do you notice now? Do you see that steam? And the water is starting to bubble. Heating the water speeds up the process of evaporation. Evaporation is the process by which water on the surface of a sample becomes a gas. When we see steam rising out of the beaker, we know that evaporation is happening. Let's add this information to our cause and effect chart. The cause is heating. What is the effect? The effect is evaporation, when a liquid turns to gas. The process of evaporation forms water vapor. Water vapor is water in the form of a gas. We can't see water vapor, but water vapor is in the steam that rises from the beaker. Let's write our observations of the properties of water while heating. What do you notice? I noticed that the sample has bubbles in the water and has steam coming out from the water. But do you notice that the water still takes the shape of the beaker? I noticed that too. Now I carefully remove the beaker from the hot plate and let the water cool for a few minutes. What do you notice about the water after cooling? Look at that! The water is clear and liquid. The water also takes the shape of the beaker. Those are the same properties we observed before heating the water. Great work recording your observations. How did the properties of water change while heating and after cooling? While heating, the sample has bubbles in the water and has steam coming up from the water. Remember, water vapor is in the steam. Since we saw steam, we know that while heating, some of the water changed from liquid to a gas. After cooling, the water's properties were the same as before heating. The steam went away after cooling. Let's heat our beaker of water one more time. But this time, when the water begins to make steam, I will use tongs to hold a round piece of glass called a watch glass over the beaker. The watch glass will be dry before I start. Ready? What do you notice on the glass? I notice little drops of water. Remember, this watch glass was dry before we put it over the beaker of hot water. Where do you think the water on the glass comes from? Do you think some of the water vapor stuck on the watch glass and turned back into a liquid? I think so too. While the water was heating, the liquid changed to a gas, water vapor. The water vapor escaped into the air in the beaker. Then some of the water vapor in the air touched the watch glass. The water vapor cooled and changed back to water. This process is called condensation. Condensation is the process by which a gas becomes a liquid. Under most conditions, condensation involves cooling a gas to a certain temperature. So cooling causes condensation. Hey, let's add this information to our cause and effect chart. Under cause, we'll write cooling. And what is the effect? The effect is condensation, when gas turns to liquid. So heating can cause water to change from a solid to a liquid, and from a liquid to a gas. And cooling can cause water to change from gas to a liquid, and from a liquid to a solid. Look closely at this photograph. What types of matter do you observe in this photograph? I see liquid water, and hey, what's that object floating in the water? It's ice. Ice is a solid. Do you notice any other types of matter? Do you see steam rising into the air? I see steam too. If we see steam, we know water vapor is present as well, and water vapor is a gas. So we see all three stages of matter in this one photograph: solid, liquid, and gas. A state is the condition in which matter exists. Ice is water in its solid state. In science, people refer to the state of matter when describing whether matter is a solid, liquid, or gas. We have examined changes between the three states of matter, which are called state changes. Hey, let's add a title to our cause and effect chart. We can call this chart State Changes. past few lessons, we have investigated the question, what happens to matter during heating and cooling? Let's update our class chart with our new knowledge. What have we learned? Well, in our investigations, we saw that matter can change state, solid, liquid, or gas, during heating and cooling. Great work! After today's lesson, your task will be to update the class chart.